Hey everybody, and welcome to the May 2021 Kubernetes Atlanta Meetup. My name is Joe Searcy, and I'll be your host on the wild ride today. Just to reiterate a couple things for housekeeping. One, we are recording this, so it'll be posted on YouTube later. CNCF kind of rules and behavior apply here. And that being said, welcome everybody again. We have a lot of good content today focused on and around all things with the Open Container Initiative, container images, and Cloud Native Artifacts. And before we jump into that content, we'll go through our normal this month in Kubernetes news section. So give me just a second here. And should be sharing a screen with the notes from our Hack and D page. If one of the panelists could give me a thumbs up that they can see that. All right, cool, thanks. So starting off with general Kubernetes release cycle, we are, there's a typo there. No, sorry, 1.21.0 was released, 1.21.1 was also just recently released. We are in the swing coming to towards the end of the 1.22 release cycle. So version 1.22.0 alpha 2 has been released. The next major deadline coming up is the exception requests. Those are due on June the 28th, followed by code freeze the following month. And then in August 4th is the planned release date for Kubernetes version 1.22. This month, we did have a series of fix releases for all of the currently supported versions of Kubernetes, so 1.21, 1.20, 1.19, and 1.18. This should be the last update to the 1.18 release branch going forward. So make sure you start looking at 1.19 or above if you're currently running on 1.18 or below. So talking through some of the promotions from the actual code development within the Kubernetes project. Index jobs are some items that we've talked about in the past that add some additional functionality to the core primitive of Kubernetes jobs. These have been promoted to beta. Namespace selector affinity has been promoted to beta. And then warning headers have been promoted to GA. And this is one that's really interesting to me. And anybody that kind of works within in and around Kubernetes admission controllers, and now a lot more items. This builds on the work that was done to introduce a framework for bubbling up warning messages for different components within the Kubernetes project. This started out as a way to sort of warn about API group and version deprecations and things of that nature. It's also has an interface for admission controllers to be able to bubble up messages that don't block or gate on an admission review response, but allow you to still give feedback to the end user. This builds on that and continues to integrate this in more ways with Kubernetes and the API server and the components itself, to where you can now provide individual warnings per field within the core API resources. So a lot of customization and flexibility that you can get there. So if you maintain any type of Kubernetes resources, admission controllers, CRDs, things of that nature, this is an area to kind of watch out for. You'll have a brand new way to sort of communicate with your end users, new feedback path, which is cool. Going into deprecations, Ingress v1 beta 1 has been deprecated. This has been talked about for quite a while now. Shouldn't be a surprise to anybody. There are some structural changes to the schema from V1 Beta 1 to V1. So, make sure you take a look at that. It's not a huge transition, but there are some things to keep in mind there. So feel free to click on the link and read more about that. We did have a few CVEs that were introduced. I'm not going to go into detail about them and whatnot, but the links are here if you want to click on those and check them out. I know there was one that was sort of like Windows node specific, and then there were some others that were kind of in the background and whatnot. One discovered via the project's, the community's bug bounty program, which is awesome to see that community participation in that. On the PRs of note, talked about the per field warning hooks. Again, I think that's super awesome. And then we have the feature gate to disable all entry cloud providers. So this is a culmination of a lot of work over the past several years, where just in the way that a lot of different components in Kubernetes have started out, where there's a lot of provider specific code that's entry to the project itself. And as different interfaces such as CSI, CRI, CNI, things of that nature have been introduced to provide a generic abstraction where people can kind of plug in versus having all the code entry with different operational overhead for maintaining that. This gives you a feature flag where you can just disable that in the API. I imagine this will be kind of by default in future versions of Kubernetes. Community news. We did have the KubeCon EU virtual conference since the last time we met here. There were many different presentations for KubeCon EU that were awesome, but there were a couple things that I pulled out that were pretty interesting. CNI working on version 2.0, and this has a lot of different implications out here. So this is a link to the sked.com where you can access the presentation artifacts as well as transcriptions and things of that nature. But a lot of interesting stuff here. If you have a lot of dependencies on specific CNI features, or you've been waiting on certain enhancements and things of that nature, dig in and see what's coming in 2.0. Another thing here is kind of a deep dive on how the cluster autoscaler scales. So this has been one of the things that's been interesting to me, whether it's been the horizontal pod autoscaler, the cluster autoscaler, these different components. They sort of share a lot of logic, and then they also have some uniqueness based on the type of resources that they're scaling. So this presentation goes into a pretty good deep dive on how the underpinnings of that work. So pretty interesting read. Now into some general community projects that I found pretty interesting. KCP, which says it's a minimal Kubernetes API. How minimal exactly? So KCP doesn't know about pods, nodes, deployment services, load balancers, etc. You get enough stuff to handle RBAC, to be able to install CRDs and a couple of other things there. So there's a lot of different use cases around this model. Some of them get very complex. Some of them are very simplistic. I won't go into a whole lot of detail here, but Kubernetes brought in the model of like this reconciliation loop pattern and declarative orchestration. And it's proven to be very useful within Kubernetes itself in many different ways. But there's also a lot of folks like Crossplane.io project comes to mind as well, that are doing things to start to control resources outside of the Kubernetes environment with these foundational components of reconcilers and watchers and things like that of Kubernetes. So this gives you a way to sort of package things up in a little bit different way, a more minimal install if you really don't need all of the other components of Kubernetes. And I know a handful of folks in the community have talked about doing this in the past and have hacked some things together. So it's really cool to see this come together in a little more formalized project. And I'm really excited to see what other people start to do with this. Another project that was pretty interesting is KubeWarden. I personally have spent a lot of time in the Kubernetes policies code space, being a maintainer of a project in this space. And I've seen a lot of different projects do things in different ways, whether you're talking about raw vanilla OPA, you're talking about something like Kyverno or Gatekeeper. And here, KubeWarden takes a slightly different approach than what we've seen with some of the other Kubernetes policy as code tools out there. So it uses kind of generic policy length, like it doesn't have a specific domain specific language or anything for policy. You just kind of write your policy in whatever code you're familiar with. And then they've done some interesting things to make that portable across the bounds of regardless of your architecture. And I thought this was very fitting in today's topics because they're relying on an OCI compliant registry to host policies for their tool to be able to push and pull policies there. So we'll bring up some topics on that, but really novel use case of an OCI registry here. And then also in line with some of the topics that we're talking about today, I think most of us have probably seen some of the stuff around the various software supply chain vulnerabilities and breaches that have happened in recent times. So being able to provide a provenance of what I build is what actually gets deployed in production and is what is still deployed and running in production, you know, a month from now, 6 months from now, or wherever. And image signing comes into play in this. And if you've tried to do anything with image signing in the past, it's been a little bit cumbersome. The tooling hasn't been super great. And from my personal experience, it hasn't really been in a place that was scalable to the average user base. So if you had to support this in like a large enterprise, it could be very, very difficult. But the SigStore project seems to be based around making that process much, much simpler and somewhat transparent to users. So really excited to see what comes out of this. And I think we'll have some things related to this come up in the topics in the roundtable discussion later. So I won't go into too much more detail here. And that wraps up this month in Kubernetes. Take this time to call out if anybody is hiring. Please post in the chat. Make sure you include information on the company, who it is, contact information for you, and a description of the position that you're hiring for. And we'll get that, we'll collect it, and we'll place that in the Meetup notes for people to be able to access later on. All right, so this is where normally I would have a co-host and they would introduce me as the first speaker, but flying somewhat solo this evening. My co-host Alex is celebrating his anniversary tonight, so happy anniversary, Alex. Hope you're having a great dinner. Let me switch gears and get my other presentation up here, and we can jump into some fun content. It's always fun juggling multiple screens. There we go. All right, if someone on the panelist group could give me a thumbs up that they can see my screen. All right, thank you. So the topic of today's theme for both talks today are kind of in and around the Cloud Native Artifact space, and somewhat specifically the OCI, Open Container Initiative, and container images in general. So in my talk, I want to kind of explore some of the more modern capabilities of being able to take what we all know and love about Kubernetes, of being able to take a container image, wrap in some YAML, deploy it out to a cluster and let it run and be happy. But what happens in a use case where, say, you have some edge compute needs, or say you want to tinker at home on some Raspberry Pis, or anything in between there, of how you start to bring in some other architectures like ARM64 and PowerPC 64, different things like that. How does that all work? How do you make sure that you have support for that? And what does it look like running in a cluster? And I'll preface this by saying I am by no means an expert in any or all of these things. This is just kind of some information that I've thrown together based on my personal experience. So bear with me here. For those of you that don't know me, my name is Joe Searcy. I'm a staff engineer with a focus on distributed systems at T-Mobile. I work with a group that maintains our T-Mobile Kubernetes engine platform. You kind of think of it as our internal Kubernetes as a service. And kind of focus on everything from running the platform, deploying the platform, automating the platform, to also the entire ecosystem and suite of components that surround that, including the container image registry. So before we jump into a lot of detail on multi-architecture stuff and even get to the point of talking about Kubernetes here, let's start by talking about OCI. And OCI, Open Container Initiative. Kubernetes has a long history of building and influencing abstractions between the users that consume Kubernetes and the underlying components that make everything kind of go around. And in the beginning, Kubernetes started out with only the Docker runtime, and that was baked directly into the Kubernetes project, into the kubelet. And then came things like Rocket and a handful of other different container runtimes. And then it started to become obvious, as most things usually do, that requiring all of the supported runtimes to be in tree of the project was extremely difficult and kind of cumbersome to maintain. So along came OCI and CRI, and I'll talk a little bit more about that in a second, to kind of save the day and make this a little more flexible. So CRI, or the Container Runtime Interface, that provides a high-level runtime that consumes a low-level runtime, or OCI, in addition to other concerns. So CRI is also worried about things like image management and distribution, storage, snapshotting, networking, and a whole lot more. So it's a much higher level thing that has a broader list of concerns. But CRI does depend on the lower level runtime to actually handle container creation, and that's where OCI comes into play. So what actually is OCI? OCI is sort of defined as a set of specifications that cover the image artifact itself, as well as the runtime environment that consumes the image. So with CRI and OCI, Kubernetes was able to sort of completely decouple the dependencies of specific runtime implementations and gained a ton of flexibility. And then kind of down the bottom, last but certainly not least, is control groups, or C groups as they're normally referenced. And C groups is just a method to allow you to allocate resources. That could be CPU time, system memory, network bandwidth, or a combination of all of those things. That's all happening under the covers when you do a Docker run, or you do a Kubernetes deployment, or something of that nature. So let's break down the OCI image specification a little bit. And OCI really breaks down into two high-level components. You have the OCI image spec, and then you have the OCI runtime spec. Really going to focus on the image spec here. There's a lot more detail out there. The specs are all available. I'll have links that go out with the Meetup notes later on, so you can click around and read through those. Read through the full specs. It's very extensive. But so let's dig a little deeper on this OCI thing, starting with the image specification. And this is by no means exhaustive of the entire spec in any way, shape, or form, but these are some of the high-level components that are relevant to the discussion today. So you have an image manifest, and this is metadata about the contents and dependencies of the image that can include content addressable identity of file system layers, or I think the official term is file system layer change set archives, but that's a lot to say. So I'm just going to say layers. Then you have the image layers, or the file system layer change set. That's simply a serializable file system, or serializable file systems and file system changes. And those are kind of combined together, and they can be distributed and unpacked to form the final runnable file system for a container. Then you have the image index, and this has kind of key specificity to the things that we're talking about today. But the image index provides a higher level manifest, which kind of index the other manifests. And these manifests provide different implementations of the image itself for like a multi-architecture thing. They can vary depending on platform, whether it's Windows or Linux, different things of that nature. But this is really the crux of supporting that multi-architecture or multi-platform design. And then you have the image config, and this is sort of a document that defines the layer and ordering of configurations, and allows for the translation into a runtime bundle. And information here can be, application specific arguments, environment variables, things of that nature. So when you start to break this down, this goes into like your Docker command or entry point type things here. So we talked about the image index, and I want to take a time to sort of dive in and look at this in a little bit more detail. Definitely don't want to go line by line and some JSON here, but want to kind of show you how this maps out to where we have this hierarchy of the image index, which is a higher level manifest, and then we have individual manifests for other things that get mapped out inside this image index. So let's zoom in a bit here. And I have some lines highlighted. So this is just doing a Docker manifest inspect on a specific container image. And here you can see that we have a list of manifests, and each of these manifests defines the digest for that specific artifact or image distribution. And here the difference is the platform architecture. So here you can see a platform architecture of AMD 64, ARM 64, and PowerPC 64 Little Endian. So these are all the same image. They're all built from the same image artifacts, the same Docker file, the same, in this case, Python application code. But each one compiles and has a different digest. And this higher order image index allows us to address them all together as one single entity, but also transfer all the information about the specific architectures to other things like Kubernetes. So now I want to kind of like draw a high level picture of when we talk about Kubernetes here in this, and by hybrid Kubernetes, it really just means a mixture of different architectures. And there's a couple things to call out here that Kubernetes today has full support for this hybrid model. You can mix and match many different platform architectures here. One caveat being that your control plane needs to, all the nodes in your control plane need to match the platform and architecture here. So if you're going to deploy a control plane that's, ARM, Linux, and ARM 64, all your control plane nodes need to be Linux and ARM 64. If you're going to deploy a control plane that's Windows, then they all need to be Windows and x86 64, whatever. Your worker nodes can be a hodgepodge mix of any and all in between. And all of the Kubernetes components already have support for this kind of stuff. So it's pretty exciting, where the back end being Kubernetes kind of already has all of these capabilities there. And it's really been the user-facing tools that have needed to catch up and make it a little bit easier to build and solve for these use cases. So what do I mean by how do we get our cake and eat it too, right? So what I just covered, Kubernetes node resources have a defined architecture. These are primitives built into Kubernetes resources to handle these different scenarios. The container runtime knows how to request a specific architecture by talking to an image registry, understanding and interpreting that image index manifest. So registries serve that up and allow that mapping of one entity to multiple digests. Image build tools now know how to update manifests linking to the multiple digests. That was something that kind of had to be manually done in the past. So really nice that that's kind of automated for you. And then we have things like Kimu that allows for emulation to where I can build an image or an artifact for multiple architectures on a single architecture. So if I have my x86 laptop here, I can build container images for ARM64, PowerPC Little Indian, different things of that nature, whereas previously that wasn't the case. So let's talk about how multi-architecture builds happen in kind of the old way, what people have been doing. And this is pretty simple. If you want to build an image for ARM64, you need an ARM64 system. You want to build an image for PowerPC 64 Little Indian, you're going to need a power-based system with the right operating system installed to be able to build that image. Docker tooling did at least make it slightly simple to where you could sort of set up remote engines that you could communicate with from a local machine. But it's still a bit cumbersome. These were like physical things or extra things that you had to pay for in like a public cloud service, all just to be able to produce an image that would run the same code from one architecture to the next. So now I want to kind of dive in and talk about this cool new tool, buildx, and how multi-architecture builds can happen today with this new advanced tooling. So Docker introduced the buildx plugin to make the whole multi-architecture build lifecycle easier for the masses. So what is buildx? Kind of straight from the docs, it says Docker buildx is a CLI plugin that extends the Docker command with the full support of the features provided by Moby Build Kit, which is a builder toolkit. So this is a kind of a reference implementation of the Moby Build Kit project. So it provides the same user experience as Docker build, but with many new features like creating scoped builder instances and building against multiple nodes concurrently. And we'll talk about some of that stuff in a little bit. You can define builders to handle your image builds. And what is a builder? Like builders allow you to create isolated build environments within a shared Docker daemon. And you can say create a builder for local testing and another builder for a remote build farm. If you got, if you're in the business of building images and you want them to be super fast and you have the physical machines out there to be able to offload it to, you can set it up and define parameters to kind of create an automated build farm with that sort of thing. Now, some of the magic here, as I mentioned, comes from Kimu and being able to simulate and emulate different architectures. So here, there's this concept of these simulators that kind of spin up per architecture or per platform that you want to support here. And all this stuff happens in the background. You don't have to do anything. It just sort of happens and it's auto magic. But essentially these, you can sort of think about them in the idea of like a container image themselves that have specific Kimu drivers and plugins and stuff built in there to emulate a target architecture as best as possible. And then you have the image index and manifest that's automatically updated appropriately to be able to do that one-to-many mapping of multiple architecture-specific digests into one name-based reference container image. So this workflow, while it looks like it has more moving pieces and everything, this all runs on my laptop. This doesn't have to shell out to anything else. I can build all of these different architectures on my single laptop, and it kind of is just magic. Now, Magic doesn't come without gotchas, so I want to keep things honest here and talk about some things that are a little weird or different. So one, buildx is still experimental. It's solid. Lots of people out there using it. It's getting pretty great adoption within the open source community. So it's not something that you need to necessarily hold off and wait on. Maybe don't build a company, and base your company on top of it just yet, but it's out there for you to use, and it's pretty simple. So image outputs with non-Docker drivers can get weird. So there's a lot of implementation detail and like different drivers to use with buildx and things of that nature. And there's some really weird things to where because this is all kind of happening in a container running on your machine versus natively on your machine, and emulations involved, different things like that. There's a little bit of indirection with like taking the actual built image from a build workflow and like passing it back to your local Docker daemon where you can do Docker image ls and see it there and whatnot. So there's a little things that are a little cumbersome there. The project is aware of it. It seems like they're moving in the right direction to help solve that or make it simpler. One thing to note here with multi-architecture builds, dependent and derivative images need to support multi-architecture as well. So if the first line in your Docker file is from Alpine, latest or whatever, Alpine has to also support a multi-architecture build, because the first thing your build workflow is going to do is pull in that derivative image or that base image and then start the process. So there's going to be this kind of time in between before like super major heavy adoption catches on, that you might come across a project that's based on another image that doesn't yet support the multi-architecture, or hasn't pushed those things out there. I've hit a couple. And it's, if you're real committed, you just go out, find their repo, open up a PR, please open up a PR and bring that to the attention that the user base wants these things. Or you can always fork it and build and maintain a copy of that image and the architecture of your needs as you need to. Another thing here is image build time scale with each architecture added. This is kind of a no-brainer, but I'll admit, like it was lost on me to begin with. And you can kind of see it when you build the multi-architectures, whatever your native architecture of the machine that you're building on is, like that build's always going to finish faster because it's using native extensions versus emulation. The others will complete, but they can take some time. And if you're building for just ARM64 in addition to AMD64, it's not going to be that big of a deal. But if you're adding on 3, 4, 5 different architectures there, build times can go into 30+ minutes there for small images. So be aware of that. Another thing to call out too is image registries have to support the newer OCI spec to handle the multi-architecture stuff appropriately. And this ties back into that image index manifest. It basically just has to be able to support those, and not every registry known to man does. So just be aware of that. I think it's OCI like spec v2 that the support was added in. So just something else to keep in mind. And then there's some things, especially in a hybrid environment, a hybrid Kubernetes environment, where you have a mixture of different architecture within your worker nodes. It could get kind of cumbersome and complex to manage affinity rules, anti-affinity rules, and taints and tolerations and such, to make sure that things land in the appropriate place on the appropriate node, the appropriate architecture as you transition into this. Realistically, nobody's going to go out and like rebuild all their images from multi-architecture day one. You're probably going to ease into it. So there's going to be this kind of ease in period where you have to do some things a little weird to make sure that everything works and continues to work as you transition images into a multi-architecture rebuild. So now I want to jump into some demos, and we'll see how these go. Had some things that were kind of not working great earlier, but we're going to see. So first thing is I just want to start with a simple multi-architecture image build and push. So give me a second to get my terminal here. Exit full screen. That's what I did. Cool. So Docker buildx. You do have to install it. Not going to go into details on that. They have good documentation to cover that sort of thing. But just run this. You can see it works for most things. I'd say there's probably 85–90% overlap. Anything Docker buildx can do, and then some. But there are some extra things in here, like the concept of the builder instances. So what I want to do is just list out my builder instances here. And I've got a few from different testing and whatnot, come with a default. As you can see here, lists out the different architectures or platforms that it supports here. Anything from your normal Linux AMD 64, your Linux S390X if you want to run on a mainframe, and everything kind of in between. You can set up multiple builders here if you have different workflows that you need to manage, and they're name addressable here. So if I want to use a specific one, I can just do a Docker buildx use and pass it the name of it. And if I type that correctly, it should work. I missed the X. Muscle memory of just Docker build is real. So that was already the one that I was using, so you won't really see a difference here. But if you need to switch between them, you can see a little asterisk next to the specific current builder in use. On here, again, I just defined two simple architectures here: normal Linux AMD 64 and then Linux ARM 64. And I've got a project here, just a simple Python project. And what I can do here is run this. And I'll break this down. Hopefully this is readable. So Docker buildx build, we're building an image. We're specifying the platforms here. So you can further scope what platforms you want to build for beyond just what's defined within the builder profile itself. So if I had 6 different architectures defined here, I could still scope this to just 2 if I wanted it different for this build versus another build and wanted to reuse the same builder over and over. And just pass in normal options to tag it. This is kind of what I want the name to be and everything. And then I'm telling it to also push it and pointing it at the local directory here. And just going to kind of kick this off and let it start running. And you can see here, because I've already built this before, that happened pretty quick. Caching is a wonderful thing. That applies here, same as always. But if you look through the logs, you can see that there are logs here that say this is working on the Linux ARM 64, this is working on the Linux AMD 64, and it's running all of the same steps from the Docker file for each of those things, and it's running it through the builder, which provides the environment that has those simulators, utilizing QEMU under the covers to emulate those architectures. And then you can see that is exporting the manifest, and then pushing the image. And this is the interesting thing, it just pushes this one thing. And if I come over here and let's go to DockerHub, got this here. See, this is the hello arch that I just pushed a minute ago. And if we come in and look at this and check out the tags here, we can now see a digest for each architecture. And we can, let me go back a little bit. Got a little mouse click happy. We see a digest for each architecture here. And we can go in and look at the individual digests and see that it's all the same things from a Docker perspective, a Docker file perspective. But the image digest is different. And again, it's that image index layer of the OCI spec that allows this one image name to kind of reference both of these all at once. So now let's take a look at some Kubernetes things here. Like, all right, we've got this image. Let's see how we plug this in and get things going from a Kubernetes perspective. So clear up the screen a little bit here. And I've got a Kubernetes cluster running, and it's got some nodes. So I'm going to do a git nodes -o wide. And here you can see I've got 6 nodes. I've got 3 control plane nodes that are ARM based. And these are Raspberry Pis. And then I've got 3 worker nodes that are x86 based, just running on KVM virtual machines. And I do have things set up to allow for workloads to schedule on the control plane nodes as well. So one thing, I'm not going to even try to call out this command because it's quite long, but it gives you a little bit better view. This just prints out the nodes again, shows our Kubernetes version, current OS and kernel version, container runtime, and then also the architecture. So if you look here in this last column, you can see that there are 3 ARM64 nodes and 3 AMD64 nodes. So Kubernetes obviously is okay with all this. Things haven't broken beyond belief. It hasn't complained. I haven't got any of those warnings surfacing up here. And let's just take a second to kind of inspect one of these nodes. If I do a describe on this node, capture the whole thing there. And just to call it out for folks that might be watching later on my personal machine, I have the kubectl command alias to K. So anytime you see me run K something, it's running the kubectl command. So I did a describe on one of the Raspberry Pis nodes here. Kubernetes does a great job of labeling things. So they have the labels built in for architecture as well as the OS here. So again, these are things that are already pre-plumbed in Kubernetes that just work out of the box with multi-architecture stuff. And yeah, so I've got this hybrid cluster. I've got nodes that are AMD64 and nodes that are ARM64. Let's now take a look at some pods. I'm going to do a -o wide here as well. And I am going to shrink the text here just a second so this all fits on one screen, just like you don't have to read all of it. The thing I want to call out here is that this column that shows like what nodes these are scheduled on we're going to be looking at this Hello Flask workload. And we've got a bunch of pods that are scheduled across different nodes across both architectures. So in this app, let me see if I still have my other window open up over here. Hopefully this won't be too jarring. But so this application, this Hello Flask application that I deployed, it's a simple Python Flask application. It hosts a couple different endpoints, and the main endpoint, all it does is print out the architecture information using Python libraries to pull the underlying node architecture. And so I am exec into one of these application nodes just to be able to run this from in the cluster. And I'm just going to do a simple for loop here that all it's doing is it's curling the Kubernetes service domain name on port 8080. And then it's sleeping for 3 seconds, and it's doing that in a loop from 1 to 100. So when I kick this off, we see that the architecture information was printed out, and it's showing AArch64, which is just another common name for ARM64 architecture. And so this is running, and in typical Kubernetes fashion, we all have a love-hate relationship with the Kubernetes service load balancer. as sometimes it can get sticky, as we're seeing here. But eventually this should cycle through, since all of the pods that match the label for this are added as endpoints to the service. There we go. We should start to see it kind of bouncing around. But you see, this is the same application, the same one that we built the image for with Docker buildx for the AMD 64 and ARM 64 architecture, running in a hybrid Kubernetes environment with both types of worker nodes in the cluster. And I'm able to interact with it. And as a user, I don't see a difference. As a consumer of the application, I don't see a difference, other than the fact that here I'm specifically highlighting out the architecture of the pod on the node behind the service. So that kind of wraps it up for the first demo there. And it just screen there. That this is possible. I didn't have to do anything really special with Kubernetes at all. Had to do a little bit of special stuff to use buildx to build and push those container images, but Kubernetes just works from there on. So really, really great work. The community that's done the work to support the multi-architecture and hybrid Kubernetes scenarios, many, many kudos to you. You've made it very simple. All right. Now, the next thing I want to do is kind of build on this concept that I've shown you, like what buildx is, how you can kind of use it to do something as simple as just here's a Python, container app and Docker file, run a build, push an image to a registry. Let's talk about how this looks in kind of the upstream world, and I'll go to GitHub, and I kicked off a release build earlier. Hopefully it, sorry. Hopefully it finished. Cool, looks like it did finish. So what I want to do is sort of review how, for the Magtape project, which is a Kubernetes policy as code tool that we open sourced at T-Mobile, and I'm one of the maintainers of, how we integrated this buildx kind of workflow into our project to produce multi-architecture builds in an automated fashion for the project itself. So I'm not going to go, we're using GitHub Actions for this project, and I don't want to go into intimate details on like all the ins and outs of GitHub Actions, but I have this image build workflow, and you can think of the workflow as a pipeline, CI/CD pipeline type thing here. And I'm going to hone in on some specific steps here. So steps define what actions we're taking within the pipeline itself. Default stuff like check out the repo so we have access to the code to do things with it. We're collecting the release tags. Since this particular workflow is building container images, we want to base that off release tags, so it's kind of automated. When you create a release on the project, it automatically triggers this workflow and your container image builds kind of kick off. So we talked about the QEMU stuff before. So this is setting up the QEMU GitHub action so that we can use that for emulation of the multiple architectures. We're setting up Docker buildx with the setup buildx action here. This just gives us all the environment to be able to run Docker buildx. We're doing a login to DockerHub to be able to push the images. And then we get into actually performing some of the steps here, where we're doing a build and push action. So we're giving it a context which maps out the path within the repository that we want to build for, telling it what Docker file to use, and then we're specifying what our target platforms could be. And I'm going to scroll back up here, a little bit of indirection here, where we have our target platforms defined up here, which are Linux AMD 64, Linux ARM 64, and Linux PowerPC 64 LE. So these are just variables substituted in here. We want to push the image when it's done, and then we're doing some variable expansion here to kind of tag the image appropriately based on the release. So we're doing a release specific tag as well as a latest tag. And this particular, the MagTape project, it has 2 different container images as part that get deployed as part of the application. So this is sort of duplicated. There's a init container that runs before the application starts up, and then the application starts up. So we do the same type of workflow for each of those containers here. So let's go back, and it did look like this finished successfully. So this is looking in my Actions tab here. And I can look here that this was for the release that I cut just before the meetup today. And we have a job for the init container and a job for the primary application container. So let's just take a look at what this looks like. We can see the call out of each of the different steps defined within the job. And we can see in setup QEMU, looks like there was some error there, not enough to trigger a failure or anything like that. That's probably part of the underlying Docker or GitHub action that we're consuming there. But we can pull through the logs here and see everything that's getting set up under the covers. We can see that we've got buildx, build with build kit. And this is probably going to go through and set up things like the builder itself. So yep, creating a new builder instance. So this is running the Docker buildx create to define the builder itself. And then doing an inspection and things of that nature. So let's just take a look there. And we can see the same information that I saw on my local machine when I ran Docker buildx ls or Docker buildx inspect on a specific builder. It's doing all this stuff inside the pipeline. And then we get into actually building and pushing the image. So all the same things that we saw on my laptop, this is happening within CI. And if we come back up and go to DockerHub again, if I can find my tab, and search for T-Mobile MagTape. If I spell correctly, autocorrect is making me earn my money today. All right. So we have our MagTape image here, and should see. There it is. Why it doesn't do them in order, I couldn't tell you. But here we see the image for the MagTape project that my automated pipeline did and push these. We see the digest for each of the 3 architectures that I built that for. So yeah, kind of as simple as that. And the reason why I wanted to call this out from the kind of project maintainer perspective of if you are building Docker images for a project that people are consuming upstream, as I mentioned before, one of the gotchas is those kind of dependent or derivative images where you can kind of like just make it a little bit easier for other folks to consume your upstream image in a derivative fashion if you provide the multi-architecture builds. And in this case, GitHub Actions, they're free. You can copy and paste, the same workflow that we're using for the MagTape project or any of the other projects that are using this type of thing out there, and kind of add it in for very low level of effort and free to just kind of start supporting that out there. So when the next person comes along, finds your project and wants to deploy it on their Raspberry Pi cluster at home, they can do that without a lot of headaches. That pretty much wraps up the demos that I wanted to take everybody through today. So I will stop sharing and see if there have been any questions from the chat. Moshe?
I haven't seen any. We did have one call out for hiring. the rest is comments.
Okay. All right, and just if you're not familiar, Zoom does have a Q&A feature that allows you to post questions. Also, you can post them to the chat as well, and we'll have one of the panelists kind of interrupt and call and read them out. Should have said that earlier, but now we all know. But cool. I'll be around later if anybody has questions, and as always, feel free to reach out and follow up one-on-one with me across Slack or GitHub or the Meetup itself. So that being said, next presenter, it's going to be really tough. I'm going to say his name real slow so you can get it. No, I'm just kidding. His name is also Joe, and he also works for T-Mobile. My good friend and colleague, Joe Lupo. He's a principal engineer at T-Mobile, has over 25 years of experience in IT, from help desk to desktop support, doing Unix stuff, storage engineering, and most recently in the past several years, kind of turned his attention to Kubernetes and our T-Mobile Kubernetes Engine platform. And he's led a lot of the work around how we're managing our kind of container image registry strategy inside T-Mobile. So whoever was just speaking, your audio was very soft and I could not hear you.
That might have been somebody in the next room.
Oh, okay. All right. Background noise. Got it. So with that introduction, I'm going to pass it over to Joe Lupo to take it from there.
Thank you very much. So my presentation is going to be on Harbor. Basically, going to do a brief overview of what Harbor is. You know, give you some ideas of where you may want to use it within your own companies. Then I'll talk about what we were looking for at T-Mobile and what the solution was that we came up with using Harbor. So Harbor is it's an open source cloud native registry project that stores, signs, and scans content. I got that right off of Harbor's documentation. Basically, it's an image registry. Supports container images and Helm charts, and as of version 2, it is an OCI compliant registry. So all that stuff Joe Searcy was talking about previously is now supported in their current versions. It handles built-in vulnerability scanning. So they by default include Claire and Trivy, though others can be added. I'm trying to remember, we were doing a project doing some runtime container security, and there was one of the vendors did provide their own plugin too, so it plugs right into Harbor to be able to scan your images at rest. It also provides image signing with Notary. It is a tool that they are hosted by the Cloud Native Computing Foundation. So it is it's one of those projects that very popular, I guess, these days. It provides a lot of different features for an open source product. They have built-in RBAC. You can either use a local database, which is how it starts out by default. And if you don't add any users, you can switch it over to also use LDAP or OIDC, so you can integrate it with your own authentication methods within your company. They provide, access, different levels of access, both to Harbor as a tool, but also to your image projects. So you can grant somebody access to only pull images. You can have it be public, so anybody can pull images. You can choose to have somebody who can strictly push images but not replace them, or somebody who can replace them and delete them. So there's different tiers of roles that you can assign. They also provide project quotas, so you can set up quotas based on disk usage as well as the total number of images. So if you wanted to make sure, one of your users didn't kind of consume all of your storage, you can kind of keep them limited from, well, doing exactly that. It provides built-in image replication. So they have a couple of models to use. You can do image pushes, and this is kind of some of the things that I will get into more detail later as to what we did at T-Mobile. There is a push replication as well as pull. So with push replication, you can set it to happen on an event. So for example, if somebody pushes an image to the registry, you can have it automatically push that to a different Harbor registry. You can also set up pulls where it pulls either from, you can match certain patterns or pull from, an entire registry to copy them all from the other side to you. You can do those manually or on a schedule. So those are not event-based, those are schedule-based for the pulls. The one limitation right now that we have found is this replication is strictly at the image layer. It replicates the images. As images get replicated, it does create the projects that are there, but it does not replicate any of the Harbor configuration itself, nor does it replicate the project configuration. So if you can configure authentication if you have multiple clusters and you configure authentication on one side to use OIDC or LDAP, you have to do the same thing on the other side separately. They are independent. Even if you have replication set up between them, if you configure projects on one side and add members, with different levels of access, you will have to repeat that on the other side because it does not replicate the project members, doesn't replicate quotas. If you generate robot accounts, which are accounts used that project owners can create. So it's kind of basically like a service account allowing you to interact with your projects and maintain a kind of static token those are not replicated between multiple environments of Harbor. They also provide a REST API for different levels of administration and project management. So you can use that to, I believe you can even use that to configure authentication, but you can use that to create new projects, to set quotas, to modify quotas, add members, different things along those lines, which I will show some of that in the demo. Actually, I can show some of that right now. I'm going to share my screen. And I don't see anybody on camera who can give me a thumbs up. Looks good, okay. So I will log into one of our Harbor instances. And you can actually see here, if you just click on the Harbor API, this provides a whole list of all the different ways you can interact with the Harbor API. And you can also authenticate here. I'm not actually doing this. It is not my real password. But you can see here, like if you want to get a list of all project members, you can try it out. You can put in a project ID, and when you choose execute, it will provide the curl information that you need to run. It'll also provide the details. It'll actually provide the response. So it's pretty interesting. They provide this, I believe, yeah, so it's a Swagger interface. And the one other thing I did want to mention was that it does, and this is something that we use, you can use for storing your images, you can actually store them locally, but you can also store them. So you can have persistent storage backing it, but you can also use S3 storage, which is what we have decided to use. So within Harbor, within T-Mobile, we didn't have many requirements for what our image registry needed, right? We obviously needed something to be highly available because this is going to be supporting our production clusters. It's going to be providing platform level tools and container images that cannot be missing, right? So if Harbor is unavailable and we have a node restart, get recreated, and we need those images, we can have outages, and that's obviously not something we can afford. We also need to support multiple data centers. T-Mobile has multiple data centers spread across the US. We need to be able to host those in these data centers in case one goes offline, or if there's communication, it gets severed between the main data centers. So this way, if the one is no longer accessible, the other one can take over, and customers can still continue to interact with it. And it also needed to support local image scanning. So we wanted our images scanned at rest. As you can see, this one, it's a big, ugly image. To scan it, it's just a matter of selecting it and choosing scan. So these are things that we required for our image registry solution. And what we used Harbor for this because it was available and it met all of our needs, and it was open source, and it seems to have good support. We decided to deploy this in our on-premise TKE platform that Joe Searcy referred to before. That's our T-Mobile Kubernetes engine. Because we are running this on-premise, we do not have access to AWS RDS. And in order to provide a geo-redundant, replicated Postgres and Redis solution, we decided to go this other route. So in order to make this highly available, we have 2 instances running in our 2 main data centers. Each one of them is basically, as far as Harbor knows, they are on their own other than the image replication. Each has its own local PVCs for the Postgres database, for the Redis database, as well as the job service files. Job service is the background process that handles scheduled jobs, scans, like if you have regular scans, if you have garbage collection, anything along those lines, the replications that are scheduled, those are all handled by the job service. So that's what it needs the persistent storage for. We have access to these. You can see here. Let me move this down so I can get the Zoom taskbar out of the way. I have 3 windows open. We have a geo site. We have this one here. This is in one of our data centers. And this other one here is in our other data center. And you can see they basically look the same, and obviously I need to run. You can see here that the replication, these projects, as I mentioned before, these projects have no images. So if we do replication, they are not picked up automatically. So that's why those don't show up here. I also probably need to run a pull. Jim's Aqua project. Nope, they're there. So yeah, as I mentioned, it does not actually replicate projects. It replicates the images, and when the image gets pulled over, it fills in the project details other than the members and such. So each of these instances is directly accessible, but there is what we call our geo name, which is a geo redundant name that we have fronted with it's a GSLB solution that we have. It was built in-house, designed in-house. It communicates with our GTMs, our global traffic managers, and sets up this name. It's the resources are kept within the cluster, and it will connect to the GTMs to actually configure this geo name. So I have an ingress here for each of these clusters that also includes the geo name, so they will listen on that. Our clusters are built, they're behind load balancers. So we have a load balance VIP, we have a wildcard certificate hosted by our ingress controller. We also have wildcard DNS entries, so we just have to, once we add the ingress entry, we don't even have to specify the certificate. It's provided by our platform. And that also includes, it covers both the direct cluster names as well as the geo names. Right now, this particular GSLB setup, it is only working on a single site. I had an upgrade just recently that did, so there is some stuff I cannot demo. I was hoping to, but we're just having trouble with the GSLB configuration. Basically, it's only set up on in one of our data centers. It won't fail over to the other one because that has to be torn down and reconfigured. The health monitors changed when I went from Harbor 1 to Harbor 2, 1.9 to Harbor 2.1. So I won't be able to actually demo the failover. But basically, we have our load balancers, our GTM layer set anyway to in a failover mode. So one site will be primary, the other site will be secondary. The reason for that is we did find that if you try to do active, the Docker push will default to push 4 layers at a time, and the initial push will use the original, whatever the first IP resolves to. The GTM is a DNS solution, just to be clear. So when somebody resolves an IP, there's a 1 second time to live, and when they resolve it, when it connects to later on to push the 5th or 6th or 7th layer, or to wrap up the actual push, it will resolve the IP again. And what we found is that some of the layers may end up on one site, some of them on the other, and then neither side has enough to make a full image. So we have it set for failover. So we basically have one cluster that's listening with this geo name. And when a customer pushes to it, they will do a push. And when that image arrives in this cluster, so this one over here, for example, this is actually running off of our Texas cluster. So when it's running off the Texas cluster, we have replication set to automatically push to the other side. So anything that arrives in this cluster, in either one of these, once it's finished pushing, it will automatically replicate to the other side. If for any reason that is missed, say one of the sites is offline, if there's a problem, or if we're doing maintenance, we do have these pulls that are currently scheduled once per hour. They will actually go in and catch up any of the images that were missed. So, and when they do the pull, basically it pulls everything. It looks at every single image. Let's see I think you can even see how long it took. The last time took 15 seconds. So even, there's a bunch of images in here. How many? 78 items. Took 15 seconds because they were all already replicated. So it just scans through, finds the layers, and marks them, it just marks it successful because it already has them.
Got a couple questions from
Sure.
Q&A panel here. So the first one is from Eric Mathis. Does it have the concept of life cycles? And Eric, feel free to add in some additional context there, but hopefully take some friendly interpretation here and say like development, production, things of that nature.
Currently, we don't have it built in to our platform. So when we provide our customers a project, we can provide them multiple projects, but really we give it's more up to the customer to handle the life cycle. So as they push images for development, as they as they move them through the kind of release to production life cycle, that is left up to the customer. It's left up to whoever's building the images and pushing them through. So
And that's,
If
I'll
Harbor
add,
has,
oh, sorry, go ahead, Lupo.
go ahead.
Oh, yeah, I was
No,
just
go
gonna say,
ahead.
like, I'll add in, like customers. So one thing that we haven't really shown is that we have a sort of orchestration or onboarding layer that sits in front of Harbor. So like our users, and when we say customers here, we typically refer to big C and little c. Big C is like people that buy our telco service. Little c is our internal customers, our development teams. They can create multiple projects within Harbor if they really wanted to have, like, project name -dev, project name -prod. And that's a model that we follow with like namespace management. But for the container registries, it really comes down to the RBAC and who has access to things. If there's a hard separation of like, these team members are dedicated to development purposes only, and they should never touch things that go to prod, they could set up a project like that. But at the end of the day, it's all the same layers in the image and things of that nature. So it starts to make slightly less sense to get granular at that level, at least with the tools available today. So a couple more questions, Lupo. This one is from Rumstead. Do you run Harbor in HA, i.e. multiple pods spread across different zones or nodes? How do you back up / expand your PVs that back up the images and charts?
So yes, we do. So our Kubernetes clusters are built with multiple availability zones. Even though we built them on site, our availability zones, each one has its, kind of stole the concept, right? Each one of our clusters has 3 sets of hardware. Each one is physically isolated from the rest. So it has its own networking equipment, its own servers, its own storage, and then they all roll up to, external, I think, like end of row switches. And so we do keep our pods spread across. We also, we're running multiple pods for any of the critical components that do support it. There are some that do not support multiple pods. Like I mentioned, the job service earlier is a single pod entity. But the core, the registry, Claire, any of the scanning tools, we run multiple pods to keep them spread. And our idea within our cluster environment is that we should be able to handle any single AZ entirely dropping off. So if we, for example, if an entire rack of equipment lost power, we should still have the capacity within 2 remaining racks to still keep this environment up and running. As far as backup and expanding PVs, so the images themselves, the images and charts, they're actually being stored not within PVs. We do have external S3 storage. It's, it is in our data center. So it's, we're using that S3 storage to store this information. So we back those up. I don't remember the exact details about how the S3 storage is backed up. That I would have to check with one of the other guys on the team. But as far as the PVs that do back up the database, we do have PVs for the databases, Redis and Postgres, as well as the job service. Those are backed up by our persistent storage software. And I did have an issue with the upgrade recently, and they did save my skin when having to work my way out of it.
All right. One other question, Mathis as well. How do you clean up old unused images?
So currently, as Joe Searcy mentioned, this platform is provided to our customers. We do provide this as a self-service environment, and we do limit their access to amount of storage. So we set quotas. We don't set quotas based on number of images. Currently, the users have to go in and delete so they go into the UI right now, and they will delete the tags. Once all the tags for a particular image are removed, the image itself is no longer there. Actually, the layers will stick around until we do a garbage collection, but they should not actually be held against their quotas once they're removed. So it is currently a manual thing, and it is left up to our little C customers to do that. So I will actually jump on something that Joe Searcy mentioned a little while ago. We do have, because of this lack of coordination between the two environments, between our two data centers at the harbor level, we have created some tools, an intake process and a tool called Harborman, or Harbor Manager basically, that will communicate to both Harbor instances and manage the groups and the projects. So when a customer wants to request a project, they will submit a ServiceNow request. Once somebody on our team reviews it, where they specify the users who need to have access, the size of it, and the name of it, we can go in and assuming everything looks good, we approve it. It kicks off some automation where it will actually generate some Git repos that store these configuration files, and then kick off a pipeline to commit those to both Harbor instances separately. And it notifies us if there happens to be a failure on either side, but it will create those projects. After that initial intake, the users can also go back and update. They only have access to update the members that have access to their group. So they can't go in and modify the name or the quota after the fact. That is something that only our team can update. When any of those are updated, again, committing to the Git repo will kick off the pipeline and run through the same API that will apply those changes to both sides. So that is kind of so the database is important in the sense that it has all the project information. If we were to lose that though, we do store all of these artifacts that we can recreate. So we can regenerate any of these configurations. So if we were to lose the name of a project, if we were to lose a project, lose the particular member list or anything like that, we can run through the automation and recreate it. So that provides us, so it kind of provides us a little, so we have two redundant environments. We also have backups, but we also have this additional layer that's kept separate from Harbor entirely and separate from all that infrastructure that we could redeploy and recreate everything, all of the projects as necessary. And then once we have the image data that's already stored on S3, we can rebuild a lost instance if necessary.
Hey, Lupo, another question. Is Harborman open source?
It is not. It's one of those tools that we were looking at. It right now it is very specific to our particular set of tools. I'm hoping that we can look at it long term and maybe it becomes another one of our projects that we do open source. But right now it's so integrated with our very specific set of CI/CD tools as well as ServiceNow and all of that I don't know how easy it would be to kind of make it a bit more generic to be used elsewhere. Hope that answers that question. The one last thing I was going to show, as you can see here, this is, these are all the replication tasks. What I'm going to do, actually, this is a good way to see which side I'm on because I look at replications. You can see which this site is the PX side, and it will push and pull from the TT side, and this is the TT side, push and pull from the PX side. Those are our two data centers, and this one is, So only the TT environment is up and run, is actually working by this geo name right now. What my plan was to, was it here? So I have this image, which is, it's an Alpine image. I just grabbed an older one. I just wanted something that I should not actually have in this environment. So let's just double check. If I go into projects, I go into test. Let's see, Alpine. Yeah, I don't think I have either of these. Oops, well, I hit Control C. All right, so right now we have two. After I push this, we should see a third one show up. So you now have this one here, 2021. This was for, it looks like it was an image from February that I pulled. You can also see here, by the way. All right, the size disappeared already, but it was like a 5 megabyte image. It defaults to it actually compresses those images. So that is this one here. Test. Alpine should have 3. Now, because that was so small, I am sure that this has already replicated. So let's go to second page, test. Alpine, and it is now there also. So if we were to look at the replication logs, so there's the event-based replication, and that copied. Gives you all the information about the basically all the layers and everything that get copied. So I push that to the one side. And now I can pull it from the other. So this is the PX cluster. I already had it on my site, on my laptop. So this image is now available on both clusters as well as with the original geo name. And there's no real reason to pull this one. This is the one I pushed from, but you see that so this image is now available on both sides. And that is it. So that covers what our solution is. We are working on a replacement for that GSLB solution I mentioned, but that is not ready yet. I was hoping to have that available today as well, but it didn't work. I started working on that the other day. But that's it. Thank you very much.
Yeah, thank you, Lupo. That was good stuff. And if anybody does have additional questions around Harbor and things of that nature, feel free to reach out in Kubernetes Slack or GitHub or anything else like that. And we can get those answered for you. So we're going to be doing something a little bit different tonight than our normal closeout. We're still going to do that. But the topics that we're discussing tonight have some particular interests, and I wanted to start a series of kind of roundtable discussions on different topics that are relevant kind of to anybody that's really doing business in this, cloud native Kubernetes space. And since we're talking about cloud native artifacts and container images and things of that nature, that kind of shapes the topic of the discussions today. So it's going to be a little bit different format. This is new, so apologies in advance if this doesn't work out well or not. We'll take feedback and improve it as time goes on. But essentially, I've got a series of slides that just have questions on them. And what I'm going to do is just kind of read through the questions. We do have some guests today that have some specific insight in certain areas. And I've talked to a handful of different people, from project maintainers to vendors that supply different toolings and things of that nature. So I'll be adding a little context and color to these things as well. But this is meant to be a community discussion. We want to have this framed from the end users, the project maintainers, the vendors, inclusive of all those different perspectives. And just kind of, answer if you feel like it, don't answer if you don't feel like it. Just a simple set of things. Zoom has the ability to raise your hand. So if you're on the attendees list and you want to respond or answer one of the questions, raise your hand. I can unmute you and we can go into the discussion. Panelists, you'll be able to unmute yourself and talk and respond. Normal rules with virtual meetups, be kind to one another. We are, CNCF sponsorship here, so all of the normal CNCF behavioral rules apply. To sum it up, don't be assholes. We are still recording this, so we can use this and reference it later on, so keep that in mind as you respond. And do ask that you try and keep your responses to like 2 minutes-ish, or under, just to be respectful, give everybody a chance to talk. That being said, I'm going to fire this up and share the screen and we'll get it started. Just a quick thumbs up from somebody on the panelists. All right, cool. So Cloud Native Artifacts Roundtable. I have this broken down into some different sections here. So we're going to start with tooling and then me sort of polling the audience ahead of this meetup and this discussion. This was an area that had a lot of questions and a lot of discussion from other folks within the community. So let's just start out. And we talked about a lot of different things tonight, both in general with the OCI spec of how it's sort of expanding to include more than just container images. Things like Helm charts, WebAssembly modules, OPA policy bundles, different things of that nature. So first question out to the community here is, what other use cases would you like to see from the OCI spec, and why is that? Why are they important to you? And don't be shy.
You want us to speak up or wait till we're called on?
Yeah, just speak up. Yeah.
Okay. Well, you tell me if this is feasible, but I could see uses for this kind of stuff out at Edge of possibly packaging things like firmware images for devices. You've got a scenario out there at Edge where you've got a lot of these devices that have security sensitivities. They're not really containers per se, but probably the firmware is executable code. And if you've got infrastructure like harbor registries that can replicate, why invent a new thing just to move that kind of stuff around? If you viewed these things like a harbor registry being really an object store that can move useful information around the world efficiently with governance and control, any form of software should be fair game. Maybe not something ridiculously huge, but say firmware for a network switch or even an edge device that might be a security camera or something. There have been stories of vicious hacks that came about because Trojan horses got bundled into these devices that end up on a network thought to be secure. And seems like there's no good reason why you couldn't package that kind of stuff in the same way, because in many ways it's the same kind of stuff.
Yeah, I think that's a great example, Steve. As a lot of things, what I've noticed when I've had conversations on these sort of topics lately, a lot of things drive back to security and mainly the supply chain security of being able to track that provenance. And I think you're spot on. We have a really great mechanism to be able to store and retrieve, various types of artifacts. And we have the onset of some really sophisticated, artifact signing and supply chain validation verification that I think would yield, well beyond just, I have a container image and I need to run that somewhere. So I think that's a great idea.
Yeah, once you're going there, you provoked a thought in me that, if you're a consumer of these devices, you're often getting things from multiple sources and putting them together. I mean, you have containers that have code that you wrote, but it also sucks in code that you didn't write, but you just want to use, have somebody vet it, sign off that it's okay to use, and put these together in combinations. But really, when you get back to these hardware devices, it's the same sort of thing. Most organizations don't build their own hardware unless you're really large. You buy them, but end up customizing it. Yet there are provenance issues. I mean, this thing might be manufactured at a place with a manufacturer you trust, but it could go through warehouses of distributors that other people have access to it and hack it. If you could have some means of unimprinting these so that you can wipe them and start from scratch when you deploy them using nothing but trusted sources, that might be super valuable.
All right, participant list back up here.
I don't want to be monopolize this. So if somebody else has something to say, please jump ahead of me. But at the beginning, you mentioned KubeWarden, and I was curious about what you're storing in that, whether that's just data, configuration information, or what's going on there.
Yeah, I think in the case of KubeWarden, it was specifically the policy artifacts, so that you could store and retrieve the policies and have a centralized resource for your policies that can be deployed to multiple locations and defined, in kind of a one-to-many way.
Yeah, so KubeWarden is a pretty interesting tool. I tried it out a little bit after the announcement. Specifically, what they store in the registries here is WASM, WebAssembly modules. And on top of the OCI spec, there's actually a kind of budding WASM in OCI spec for how to properly stick WASM modules into an OCI image. And that's what KubeWarden uses, so that you can take advantage of a couple different WASM specific tools for getting these things into the registry as well as pulling them out.
Yeah, that's a good point, Dan. And we've seen similar things within the WebAssembly world, like Solo.io's WebAssembly Hub is essentially an OCI compliant registry that's able to tie in and allow different tool sets to pull WASM modules for different deployment scenarios. So yet another great example, building on top of the container images, the Helm charts, the policies and everything. So. Okay. Provided time, we can always come back and revisit some of these. If you don't feel like speaking up now, feel free to post them in the Atlanta Kubernetes Meetup Slack channel and the Kubernetes Slack org. Open an issue on our GitHub account or post them as a comment on the Meetup event itself. But let's move on. So with tools like buildx, what we just talked about here, do you think you'll incorporate multi-arch builds into your workflows now that it's simpler? And this can be your workflows like within your own company. If you're a project maintainer, this could be things geared up towards the open source way. And as an example, one of the gotchas that I called out in the kind of derivative image builds, the MagTape project that I maintain just added in the workflow to be able to build the multi-architecture images, and I take that and run the install on my Raspberry Pi cluster, and it starts to fail. And why does it start to fail? Well, MagTape utilizes Open Policy Agent on the covers, and call out the Torn and the folks over at the Open Policy Agent project. but they don't support the multi-arch builds yet. So, you know, while my application starts up and runs, when it does a call out to OPA to actually assess the policy, you know, it's like, oh, no, I pulled an x86 image and I'm on an ARM64 platform. So sorry.
So I'm using this on my personal projects, and it's great. I have Kubernetes cluster at home, runs on Raspberry Pis. So you know, having ARM64 to run there is great. And then my laptop is AMD 64, so I can debug locally as well. So I love it. We're not using it at work yet, but another use case to keep in mind is you know, AWS's Graviton instance types. Those are ARM64, and those are getting pretty popular. And there's some big price savings to have from them too. So start pulling those into Kubernetes clusters as well.
Absolutely.
Can I ask you a possibly uninformed question, but it just strikes me that if the end result of this is that you've bundled in a bunch of these different architectures, and it seems to me like the number of architectures is growing, and maybe that's a good thing. Do I have an unfounded fear that these things could be like oppressively big? Like there's a downside to moving these out to edge locations if a particular one is only going to use exactly one of those architectures, yet you paid the price of moving this big bundle, whether you need it or not.
So I'll take a stab at answering that. And again, I am by no means an expert in the low-level happenings and all these things, but the way that I've read through the OCI spec and sort of understand at least the underpinnings of the components within Kubernetes is things like the kubelet and container runtime services, like they're aware of their architecture, and they're able to, when they request an image from a registry, my understanding is that they're not pulling all of the digests available behind that manifest. They're filtering it for their particular architecture first. And then in the case of Kubernetes, if it doesn't detect a matching architecture within the manifest for its own architecture, it will pass through and default to the AMD 64 architecture. And that's how you end up with, like, I can 100%, you know, kubectl apply -f this YAML, and, you know, pods start trying to come up and whatnot, and you'll see some really obscure, not super helpful errors in the logs of your pods when they start up, if it's an architecture mismatch. So I think, you know, obviously that doesn't answer for all cases and all methods of distribution and things like that, but I think at least in the case of Kubernetes, there's some smarts in the underlying platform to help prevent, you know, biting off more than you need.
Yeah, I wouldn't expect it to pull at the exact endpoint, but the issue is if this is going through multiple tiers of container registries, you know, like harbors, whether it is engaging in all of that movement all the way up to the point near the endpoint, it might still be wasted bandwidth consumption and wasted storage.
Yeah, I think, kind of just thinking off the top of my head, as you're saying that, I think, say within a project like Harbor, where you're able to build replication rules for different things, you know, being able to provide architecture type filters to those replication rules, I think would be a really slick way to potentially solve for that, you know, at least for container images and Kubernetes.
Yeah. I just don't know if it's fair for a registry to go ahead and unilaterally strip out what it deems to be unnecessary and not violate signing rules and things. You know, you've basically transformed it to be less than the original package at your own risk, but whether that works in practice, I just don't know. I'm just curious because I could see a reason for that. I mean, at Edge, if you're talking something like a retail store, they usually want a scenario where they can cycle from a power loss, come back up, and hold a registry local to that facility to manage to pull that off. But they don't want to pay the cost of, you know, let's say 10 years from now, 10 processors have become popular, yet a particular organization only uses one or two. they have a legit need to eliminate what they don't intend to ever use.
There's an interesting alternative there, which you could almost imagine. So one of the hot things right now is reproducible builds. If you're operating under a system like Nix or something like that that does reproducible builds, maybe you could just ship actually the source and assigned manifest out to your edge locations, and then actually do the compile there.
That's
Generate-
interesting because it might be really small too.
It might, the source, may end up being tiny compared to, whatever kind of executable stuff you're building. And Go is an excellent example of kind of like stripping out all of the stuff that, like, just because I include a package doesn't mean I'm shipping all of that stuff. I'm shipping the things that the type system has identified that I need. I think we can't forget the compilation and build element to this, because I think that's evolving a lot right now too.
Yeah, look at the historical model. Like, once again, I don't know, but if you look at Linux packaging, it arguably might have had the same issue, RPMs or Debian packages. Both could be targeted at ARM, x86, PowerPC, whatever, a huge list. But did anybody ever do a Deb or RPM that has them all bundled into an Uber package? As far as I know, the answer is no, because when I download those things, I point to exactly one architecture, and I've never seen one that said it would have everything you would ever possibly use bundled in there. So why is that? I mean, is that a different world where the advantages didn't exist there, or, what's going on?
Yeah, I have seen some of the mobile manufacturers, the Apples and the Samsungs of the world, start to do that with app bundles, or I think some name like that, where they'll ship one artifact that could have the code for running on iPad versus a phone versus tablet, Apple Silicon architecture versus x86 architecture, things like that. And then the actual deploy time artifact, like the distribution of that, it is larger. But then upon install time or execution runtime, it filters that stuff out in the background for all of the platforms architectures that it doesn't need. So it solves part of the problem, but not the entire thing.
I guess you're right. I come to think of it, for generic software, I've seen zip files you download that have a Windows version, a Mac version, a Linux version, all in one zip file. You figure out what you actually want by de-archiving that and filtering through the result. But then you ask yourself, well, who did it benefit? Maybe the publisher, because they only had to publish one thing. Maybe if there's a logistics thing who moves stuff around, they only have to track one thing. But for the actual user at the endpoint, I don't see how it benefited them at all, really, because they have to do the work of finding what part of that they wanted, unless they're actually in a weird position of needing to use literally all of them.
Okay, yep. Good discussion on that. So I think we kind of covered the like multi-architecture build stuff here. So I'm going to skip that question. But what tools is everybody kind of finding to or starting to rely on to help with your container image management within your own workflows? I know I don't see Scott still online, but Scott that was on previously is a big fan of the KO tool for sort of simplifying the whole bundle of take my code, build my image, and deploy all the necessary YAML stuff to Kubernetes, all in kind of one fell swoop. But is anybody else using things? I know like Scopio's out there to help with some stuff, but what else are people using?
I'm not using it yet, but I'm real excited about Kraken. If you've seen Kraken, the Uber container distribution mechanism. So that's definitely on my short list as far as things that I want to implement. Just from the perspective of having your images on your existing set of machines. You know, I'm a big fan of using ephemeral architecture, so like spot instances. So the idea of a spot instance coming up, it gets into the cluster, it gets this kind of peer-to-peer registry deployed on it, and it has all those images a priori. Super exciting to me.
Yeah, that's been a big topic for us in our environment. There's Kraken and Dragonfly is another tool, very, very similar that both, I believe, are in the process or have some slight integration with the Harbor registry so far. So it's really cool to have all that like bundled together, but using peer-to-peer to further distributes the like layer distribution beyond just a single centralized endpoint, which if your registry's you know, on a SaaS provider and, you know, assuming infinite scalability and all that stuff, you know, like who cares? But if you're having to manage your own registry for one reason or another, distributing it out is pretty handy.
Dumb question, but I remember like a couple of years ago when everyone started to build like container images inside of Jenkins, they would all like expose the not the Docker port, what's the word that
The socket.
yeah, they would expose like the Docker socket out, which seemed like really counter to, you know, like the point of having like containers. And I was wondering, like now, you know, we're all running like build processes in like GitHub Actions or GitLab runners or whatever, which are already like sort of like a container that you build your container inside of, and there doesn't really seem to be any issue with that. Does anyone know, like, how are those things done where you're building these containers inside of containers? Has anyone had any experience with that? I know I took a look at like a project called Canico for that, but I didn't know if anyone actually that we knew actually had like some experience doing that.
I can give a little overview here. I actually started the Canico project years and years ago for this exact use case. Yeah, stuff has changed recently, and I'm a little out of date. It might be easier to run Docker inside of Docker without extra privileges for stuff like with new stuff like the rootless containers, but I think you need to be on pretty new versions of the kernel, and I've never really gotten it to work. Yeah, so Canico is one option for building containers inside of containers without any extra permissions and stuff, particularly if you're in a Kubernetes cluster where you don't have access to like the -- privilege flag or anything like that. But if you're using a service like GitHub Actions or any of the other container builder services, most of those just use VM for every single build, and they just kind of map it in the Docker socket like you talked about at first. It's not really safe, but most of those end up throwing away the VM and giving you a new one every single time. I believe that's how GitHub Actions works.
Yeah.
Today I learned.
And I think that's a good distinction of if you're operating in a, you know, assumed sort of ephemeral environment like a GitHub Actions or something like that, you know, the overall security risk is lower. I'll say supply chain vulnerabilities, whole new, you know, attack vector that may bring that back up, but you know, definitely not something if you've got, you know, your production Kubernetes clusters in your environment with actual applications running on that, you probably don't want to toss your you know, your GitLab CI runners or your Jenkins runners or whatever on that same cluster where you are either running something in privilege mode or you know, melting in the Docker socket there. And I do know I've seen other tools like buildx with the DAH, and I think even Podman has some capabilities to build images without access to a like container runtime socket interface. So there's some stuff like that. I don't know the you know, like way out of like performance build times and things like that. in one of those type of environments or using one of those tools versus, the classic, Docker build this, that, or the other. But that'd be interesting to kind of compare.
Yeah, there's one question in here. If Canico uses ptrace. No, Canico uses even more terrible, dirty hacks. Canico doesn't use anything smart. It runs pretty much anywhere. It executes your builds. It takes a full snapshot of your file system, literally just by looking at every file recursively. And then it runs your commands, and then it looks at all the files again to see what changed. It turns out to be way faster than it sounds, but still pretty slow. So it's workable. You can drop it and run it anywhere where you can run ls and stat. But it is slow.
Slow but awesome. That sounds amazing.
Yeah, we made it years and years ago because there was nothing else, and I always imagined something better would come along, and we're still here, and people are still using it.
Cool.
Why do you think more people don't use the ephemeral VM strategy there?
It's just annoying, and VMs have to start up, so then you end up making some kind of service to pool the VMs, so they're there and running. If it takes 30 seconds to start a VM and get it ready, then you probably would have finished already with Canico or something else, unless you build something to keep them warm and ready and throw them away, and then you've written a whole bunch of code that you didn't really need to save a couple seconds here and there.
Yeah, it's true.
So switching gears to a new topic, since again, it's very hard to talk about any of these things without sort of driving back to security in some way, shape, or form. But a specific security focused question here. Do you currently incorporate container image scanning or signing into your workflows? And then kind of as follow-up, why or why not? If you do, what tools are you using? And then are you doing that at build time only, deploy time, runtime, all of the above? I can kind of kick it off and say for us that image scanning is something we do today, and we are using that as part of our Harbor container registry. And we have a policy set up that vulnerability scans happen on push. So as soon as an image is pushed to the registry, the underlying security tooling kicks off and starts to produce those scans. And I know Harbor has the ability to kind of fan out that policy a little bit more to where you can do things like, say, you won't allow image pulls if there are vulnerabilities discovered of medium severity or higher or things of that nature. Image signings on our roadmap, it's been very, very cumbersome to get any type of model that we feel like we could scale out and actually use across the enterprise. So Dan, I think you have done some work kind of in that area around the signing and stuff like that. Do you have any coloration there to add of like how things might get simpler or easier?
I think it's getting simpler pretty quick now, finally. Up until now, there's kind of only really been one option if you wanted to do this, which was like Docker Notary V1, it was called, or Docker Content Trust. Which worked pretty well, but the problem was it kind of required a whole separate service people had to operate instead of just the registry. So it was kind of like a whole separate database that people had to set up. So only Docker and a couple of other registries ended up supporting it. So it was kind of challenging. I've been working with a project called Cosign, COSIGN, if you look that up, to do signing for containers where everything is just in the registry. So it works on Harbor, it works on any registry that you can push Docker images to. Started only a couple of months ago, but some people are already using it in production, and it's kind of like the only more recent option that I've found. And it works with some other hacks, like the signatures actually get stored as other OCI images in the registry, like we were talking about before with WASM and other stuff like that. But you can sign with YubiKeys, you can sign with KMS tokens, a whole bunch of other methods like that. So enterprises, I think the challenge is really then coming down to like how you actually want to manage keys and who you want to trust to be signing. But the actual how to sign, when you figured out those problems, is more solved now.
So I see Rumstead, it looks like you have your hand raised. Feel free to unmute and chime in if you have anything to say.
Yeah, so thanks for calling on me. Our company uses Aquasec and its suite of tools to be able to do build time scanning and runtime scanning. And I was just wondering how you all handle false positives with some of these scanning tools. I've tried Sync and Trivy before. Trivy, I think, is part of Aquasec now. And, you know, we get false positives that is a sync because our InfoSec team will, you know, deny it running using probably an OPA policy under the covers by the Aquasec enforcers. And, you know, you have to validate these issues, prove to them why we're either not vulnerable or why it's no longer an issue. And I was just curious how you all and your companies handle, you know, remediation of the vulnerabilities and also like the false positives and kind of the toil there.
Yeah, I think we're sort of in a similar place with similar tooling, and that's why I mentioned with like Harbor that you have the ability to define those policies to prevent images from being pulled that have high vulnerabilities discovered. I didn't say that we have those enforcing yet in all of our environments, because like false positives, and especially with derivative images and things like that, it gets really, really hard to even control that or influence that. You know, if you're consuming something upstream, like we all love to say, like, oh, you know, we vet everything and we're not going to just, you know, pull copy and paste from you know, Joe Blow's project X or whatever, but sometimes it happens. And getting into like, we're in this middle place to where like we either have to deal with the false positives to live within the bounds of, you know, like our auditors and things of that nature, or we end up having to sort of take over the operational burden of maintaining an upstream image internally, where it's like, yep, this is Alpine, my Docker file looks exactly like that one over there, but because I ran it in here and built it internally, you know, that gets the blessing, you know, this, that, or the other, which honestly is still not a great option either. So I'd say from my experience in our enterprise, I don't have a good response of anything to solve the problems, but we are commiserate in that we experience the exact same problems.
I think that's a common problem across the board. Like even coming from my last gig, I think, you know, we had several issues with, you know, just making sure that the CVE manifests were up to date and things like that. It's not uncommon from my experience.
Well, when you say false positives, there's a couple different types there too that need different treatment. There's the ones where the scanner, you know, picks up a package that might not actually be in your image or might not be used, so it doesn't affect you. The other ones, though, are like the tougher one is where there's a CVE that's just not valid, and you have almost nothing you can do about that. There's and we see those in Debian things all the time, where the maintainers have to, the maintainers have to kind of contest these CVEs, and they don't really care, so they don't go through the huge process of getting these CVEs removed.
Yeah, I would even say there's a third category too of whenever they patch it, they'll, you know, the CVE might be in the latest release, and then they'll patch it back in previous versions, and then the scanner still picks them up. But that's the one that annoys me the most, honestly. The other ones, Debian doesn't fix a lot of issues that get scanned. We kind of just accept that.
Yeah, I think one of the other things with false positives too, like they can sort of go, you know, in the other direction as well. And through some of the testing, as we evaluated different, you know, container runtime security solutions, you know, we were able to take an image that had like a known, you know, like benign, but as far as behavior and whatnot, activity where it, like, you know, syncs up to a Bitcoin miner running out in AWS. And we were able to deploy those, and not a single tool picked up that type of scenario or behavior or packages, you know, through any type of vulnerability scanning. And so, you know, that was a controlled scenario where we were doing it on purpose and kind of like specifically looking for some edge cases and things of that nature. But all of this vulnerability stuff is built off database and discovery and things of that nature to check against. So You know, it's a never-ending battle, that's for sure.
Yeah, actually during that project, one of the tests that I had was going through the scans and seeing which ones, comparing the different tools like sysdig and aquasec, comparing the results on a set of known bad images and seeing which vulnerabilities were found and finding how many disparities there were, and then having to dig in and just figure out why one found a particular vulnerability that turned out to not be real while the other ones didn't pick it up, or while they all, you know, some of them were found on all the platforms were all wrong. It's a very very frustrating exercise to go through and see how many false positives and how many, you know, misses there were across the board.
Yeah, it's not even really about like one tool versus another tool. At a certain point, when there's just disparity between all the tools, you just start to lose confidence in the concept of the tool space altogether.
There's just so many
Yeah.
different sources, right, where they're pulling that information from, and I think that's the disconnect there. So, like, you know, you take Sysdig, for example, right? They're pulling from main core and a couple other places, and same thing with aquasec, right? And I think that's where the disconnect happens a lot of the time, is one project maybe pulling from a certain set of list, and then another project's pulling from a different set of list, and there's just disparity there.
Yeah, not just the list, but also how you're checking. You know, some of these tools are checking like actual file hashes, but maybe they'll find a file hash that's consistent with a specific package that had a CVE, but it turns out that you updated and that file, like the CVE was valid for the package that the file was in, but you don't use that file. That file is never loaded from disk. I was going to ask because I have actually been I've been directed, although I have a lot of cynicism about this. I've been directed to a couple of different tools that will do some dynamic analysis on your containers to basically say, what are your containers actually loading from disk and like executing? Is anybody using any of those? There's some, I think it's Slim or something like that. I'll have to remember, but I just have a lot of skepticism about those kinds of tools because they don't actually understand the operation of the program. But you know, something like that could decrease your container image size and also you know, theoretically exclude some vulnerable components if it were effective.
Yeah, not an area that I've had experience with.
Well, in that container runtime security project, we had, I don't remember which vendor, but they actually provided a service where you would push your container, you know, they would actually push the container to their own site. So they had a kind of space where they can start up the container and scan it, you know, see what stuff actually came up on start and see what it tried to connect to, and you know, and they had it all protected and everything. It did not, I don't remember which vendor it is, but it did not capture that Bitcoin miner that Searcy referenced before.
All of my Bitcoin
It's supposed to be
miners are
super.
totally legitimate.
Yeah.
Okay, so let's jump on kind of still in the same vein of security, and we've touched on it a little bit, but moving into the supply chain here, you know, there's been a couple different supply chain breaches over the past couple years that reading through it, you know, have scared the heck out of me in a lot of different ways. You know, as a person that works in a large enterprise that, you know, we get software from lots of different vendors and lots of different sources and things of that nature. And there's always a balance of like not getting in the way of your users and making things simple and easy and having a good user experience, but also being secure and not, you know, especially in these kind of like multi-tenant platforms like Kubernetes, you know, not open yourself up to a whole nother, you know, realm of issues. But with any of that, has anybody had kind of like either themselves personally or within the organization kind of had a pretty big reaction that's taken you to start looking at these things like much more seriously? And if so, you know, what are some of the things that you are looking at?
I think from the organizations I've been a part of, you know, no one is aggressively trying to track these things, unfortunately. I think there's a lot of, you know, willingness to say, oh well, that's, you know, I'm close enough to the middle of the pack that wouldn't sort of end up affecting me. Especially at the upper levels, you know, they probably don't really have strong concerns about this. You know, on the other hand, the things that we have implemented are really pretty generic at the network level, kind of, you know, just understanding what our outbound connectivity is and trying to avoid, you know, having sort of blind spots on the network level, as far as, because, you know, at the end of the day, the only thing that might make it in a supply chain breach but doesn't reach back out would be like a crypto locker kind of scenario, which of course those are certainly very real, but you know, generally in Kubernetes we're not running a huge number of stateful workloads, so not. And if you are, you're probably backing them up because you're running them in Kubernetes. So it's kind of less of a concern.
Yeah, I think the big concern for me and you know, my organization is it's taken, you know, big companies a very long time to really to trust in open source in a lot of ways, and nothing to do with like open source isn't trustworthy. It's just a big business, you know, things that come for free, there's got to be a catch sort of thing, you know. But just look at a single individual Kubernetes clusters these days, and you've got, you know, something that you're installing to manage persistent storage. You've got something you're installing to manage, you know, your network, your CNI stuff. You've got something for ingress. You've got, you know, service mesh. You've got, you know, database as a service tooling. You've got all these different things. And the average company, you know, probably isn't going through with a fine-tooth comb. Like, they're putting a lot of trust in the upstream maintainers and the upstream communities to like manage that sort of thing. So that's where my, you know, we don't ship a lot of software that we expose to the public world, and I think, you know, there's that makes a little bit of a difference, but we consume a heck of a lot of open source software. So I'd say that to me is what sits in the back of my mind and makes me worry. And again, I think there's also some unique opportunities with using open source software versus closed source software. You know, I do think the main advantage is that you've got more eyes. You will, you know, hopefully discover these things more quickly, and have, you know, a multitude of people that are invested in solving that problem, versus, you know, like, you know, somebody waiting on a check to be signed and written and cashed, you know.
I mean, I think one of the interesting things is that, you know, just as much as we've seen, you know, strong evolutions in the container space, we've also seen a lot of strong evolution in the security engineering space. So, you know, tooling that's available to check your network traffic, to automatically remediate things that you think might be, you know, malicious. All of that stuff is it's come a long way, and it's continuing to evolve pretty rapidly. Of course, the attackers are evolving adjusted rapidly, which is one of the trickiest parts. But you know, I think it's kind of an unfortunate reality that you know, there's never going to be an end to this, and you know, nobody you know, I think back to the Andy Grove, like, you know, only the paranoid survive in some regards. Yeah, you know, sleep with one eye open. I went to DEF CON at the last in-person DEF CON, and one of the Sky Talks was literally a guy scanning every public IP address for the kubelet ports. And you know, it's like he had all of them. Like, I think he had, like, you know, 20 or 30,000 open kubelet ports, a good number of those that were, you know, just so, you know, I think the TLDR of that is, you know, try to use Aquasec to its greatest capability. Try to use whatever vendor you can. And you know, follow the benchmarks, CIS benchmarks. Huge fan of those.
Yeah, good call out. So switch gears a little bit, and again, we've touched on it. It's hard to talk about any of these one topics without, you know, kind of hitting, you know, cross-cutting concerns here. But moving on to availability here, this has been something that's come up too, because we have multiple container registries at T-Mobile. And you know, we have a split hybrid environment with public cloud and private cloud. So when it comes to availability of those images, you know, like if I can't pull my image, my pod can't start up. That means that, like, one that's previously failed due to, say, a rolling update of the platform itself. You know, I'm upgrading my Kubernetes nodes. Pods can't come up and resolve themselves, or I had an application error and it, you know, fails over, needs to schedule on a different node and it can't pull its image. So that sort of framed, you know, are you using SaaS only based registries like DockerHub and GCR, ECR, things like that? Do you have only self-hosted? Do you have a hybrid model? Do you have a DR plan? Are you doing any type of mirroring or pull-through caching and things like that to solve for availability concerns?
Yeah, I mean, I'm happy to say what we're doing, and that's SaaS only, you know, but at the same time, our DR plan really revolves around, I mean, we're a small team. Any one of us could build any of our containers from the Git repo. You know, it's really relatively trivial to do that. So our mean time to recovery objectives are looser probably than a telco, for example. You know, we measure them in hours. You know, we feel pretty good about it, I think, for the most part.
Yeah. Yeah, and that, I think that's a good point to bring up too, is, you know, we have somewhere in the neighborhood of, you know, thousands of applications, you know, different applications, and you know, tens of thousands of instances and things of that nature. And even though we're all, you know, all of our development teams are under one umbrella, it's a big enough organization of, you know, thousands of people that you know, there is bifurcation and some standardization and things of that nature, and there's a lot of varying skill levels. You know, some teams are way more mature than other teams, and they could easily rebuild their Docker container images from a repo, you know, on the spot. Other teams would be like sort of hard pressed. And we do try to push, you know, a DevOps GitOps mindset with using CI/CD, you know, automation to push, you know, from a repo out into a running production environment. And I think that solves a lot of it. But in specific moments, you know, we've seen some outages with our SaaS provider registry. where we go through and we're doing maintenance on a Kubernetes cluster, and we, like roll through each node. Pods get evicted, they get rescheduled elsewhere. They're not able to pull their images. And it's like, if the applications have something like a pod disruption budget in place that can sort of gate that upgrade procedure, awesome. If they don't, you can roll through a whole cluster and upgrade every node, which means every pod's going to get evicted and rescheduled, and everything's down. So like that's been a big concern for us, is how do we balance that? And for us right now, like our on-premise systems and on-premise environments, like we just don't feel comfortable accepting the risk of building a dependency on like a public like SaaS registry.
Yeah, it's interesting that you mentioned like rolling through instances. Is there any, what? Yeah, no.
Yeah, something like a Dragonfly or a Kraken would absolutely help in this nature, because then that new instance could like pull from its peer nodes, assuming that we don't lose all nodes at the same time or something like that,
Right.
I feel like is a fairly safe assumption these days, but not impossible. But I do think those are some of the technologies that we're looking at to kind of aid in those scenarios.
Yeah. And then, I kind of want to think a little more about, because like, from an attacker mindset, going back to the supply chain, the registry is really, gold there. If you can get sort of some kind of access to that, you can do all kinds of things. I guess one question, because, so like by convention, we tag every image with the Git commit that it came from, right? Which, okay, great. We can build it from that Git commit in source control, but that's just you saying, okay, this image is this Git commit, you tag it yourself. So I guess one question that I had is, and it's kind of, I wanted to ask a little more about to Dan about cosign, because we already have like pretty robust PKI systems in some places, things like Git that have, even people that have never used GPG before, if they've downloaded the GitHub client, then their commits are already GPG signed with whatever it is that the Git client uses. Is there any saving that, or do you think we need to?
So I think like the model is still applicable at like the core component layers, and this is some of the stuff. It's been a minute since I like did the hands-on evaluation of this, but I dug real deep into like the container image signing with Notary and things of that nature. It's probably been about 2.5 years ago now, but it's super easy if you're one developer. You have, God mode access to all artifacts, all systems, all tools, and things like that. It's trivial. When you start talking about distributing that within a like larger organization, it's like, okay, well, who actually has the access to the keys to sign things? If you just give that to everybody, then like it's no different anymore than, it starts to lose the meaning of being a credential, essentially, right? But there's also some stuff where, how do you build that into a CI system that runs in a kind of autonomous mode, outside of an individual with an individual's credential? There are other concerns like that too. And then I think one of the things that Dan mentioned that's interesting about cosign is the distribution of kind of the provenance and the signing metadata to the registry itself. Otherwise, and again, it's been a while since I looked into the details, but I think there was some things of like, when you pull an image, you have to understand how to talk out to like a system for verification of the signature and things of that nature. And so there's a lot of complexity there, and there's a lot of room for things to go wrong, even on like very acute, inconsequential like network blips and things of that nature. So I think there's a lot of room for improvement over just the here's my GPG key and sign it and shove it somewhere type thing. When you start to move beyond, you know, a single or a small group of developers that need to manage, you know, an artifact or an image or something like that.
Yeah, I think that is the trickiest part, because, you know, I feel like, you know, a lot of the folks that are really, it just reminds me of the Steve Ballmer, like developers, you know, it's like, make it easy for a developer with a YubiKey, right? Which is great. Like that absolutely needs to happen. But then how do we build something that's higher assurance, you know, something that's like, okay, it was signed by, you know, the builder in a specific way, be that whatever kind of system, CI system or that you're talking about. And then it was signed by the Harbor Registry, which did the vulnerability scans, you know.
Yeah. One of the other things that's kind of coming to mind now as I'm recalling some of the stuff I did is like in an HA scenario, you can't really replicate trust signatures like information. Like it defeats the purpose. And so like if you're trying to deploy in like a multi-region, multi-data center type model, there's a lot of things like just technical problems that still aren't solved. At least, you know, from the last time I looked into the stuff, that even, you know, Harbor as a, you know, pretty large open source project with tons of adoption, like they just flat out, they're like, yes, we support notary image signing on a single instance. If you have multiple instances, sorry, it just doesn't work today. So like there's a ton of complexity around that specifically that I think throws a little bit of the wrench in there. And that's where like distributing that metadata and stuff, and at least in how Dan was describing it, seems like there's some promise to solve that problem too.
Yeah. I'll be excited when we get there, for sure.
It kind of seems like Bitcoin already solved all of those problems, right? And all those, each thing gets signed, it's out in the public. You just have to go look.
Yeah, I think there's definitely some concepts to borrow from there. Just not sure. It's not something I've looked into specifically to know like why that's not just like you know, Hyperledger just isn't the magic key or not. You know, I don't know if somebody's already exploring that or not. That'd be a good question to the rest of the community. So I think we talked about distribution earlier, so I won't go much more into this one, but you know, some of the things that Steve touched on with distributing images over low bandwidth connections or in places where you have limited physical access, or untrained staffs in like a retail store that's going to look at you really funny if you ask them to like plug in a USB drive to a server in the break room and, you know, run a kubectl command or a Docker command or something like that, you know. So and then I think we also touched on some of the lifecycle stuff too, with like the concept of golden images and things of that nature. But just real quick, does anybody treat images differently between like development versus QA versus production?
I try not to, but one thing that actually bothered me the other day was in Go there's no good way to sort of like import selectively like for libraries, or have sort of like compiler. I mean, Go has some sort of like compiler directive that has like what do you call it, pragams or what have you. But if you want to say like only run performance profiling in one environment and not in like production. Like there's no really good way to do that without, you know, like building different images or like not exposing certain things in different environments that you pass in like through environmental variables or something. Like you don't expose a port.
Yeah, and even with environment variables, like you're still baking in those libraries and deploying it to a bunch of places that probably don't need it or where you don't want it. And that's, I have seen, I'm trying to remember the specific idiom that I've seen that it was used for some like distroless or scratch container images where like if you need to troubleshoot something, you literally don't have any other binary utilities to run to, you know, PS or anything like that. People had what was essentially like a debug, you know, a tag that was, everything else is the exact same, but they like added in the debug tag, specifically added in some other kind of like tools and binary utilities to help troubleshoot. So their typical workflow was, you know, we deploy in CI the you know the production, you know, the release tag version, and as long as everything's good, then we don't have anything. But if we need to triage something or troubleshoot something, you know, we deploy that debug tag and have access to be able to you know, the different troubleshooting tool sets and things of that nature. But the debug is what, like, it's never meant to be deployed to production. It's for like kind of development only, you know, probably not even CI to most degree.
I wish there was a way to sort of do that live. Like if you wanted to quarantine a running pod, you cut off traffic to it, and then like the way that, you know, we deploy with like distro lists, it's not really, you still can't get like in the pod or, you know, to like use the debug in the way that you're describing. You have to like reproduce that issue as best you can in a local environment.
Yeah, I think there's a lot of capabilities that we have today that get us pretty close. There's always going to be some, you know, minute differences, but like kubectl debug, it just injects, you know, an extra container of your choosing into the existing pod. So that gets pretty close, right? Where you don't have to inject those, you know, binary utilities for troubleshooting into your application image itself. But because of the shared, you know, network namespace, process namespace, you know, the nature of C groups and container runtimes and all that jazz, you know, we can get pretty close. You know, I'm sure there are, nothing comes to mind right now, but like I'm sure there are some scenarios where like you just flat out need to have the utility in your application container. But at least we do have tooling like the you know, shared network namespace, process namespace, and kubectl debug.
Yeah,
Yeah.
I mean, I kind of always want to say, like, can you just log more? You know, and I know that that's not always a good answer, but like that's the answer that I want to give. The other answer, and I wonder if there is a thing like this, which will like take your container as you've built your container to run it however you would normally run it, and then run it with like a remote, depends on what kind of debugging you want to do, but like a remote GDB session or something like that, to be like, oh, my thing is running, but it's already running in GDB, so I can just connect and you know, set a breakpoint and go.
Yeah, that would be interesting. So we're pretty good over the initial time that I thought we would be going for this, which is great. This has been a fantastic discussion. Thanks for everybody that started out with us, and especially those that have finished with us here. To wrap everything up for this meetup, let us know if you enjoyed the kind of roundtable discussion type thing, or if there are any other topics that you'd like us to do a roundtable on in the future. You know, it's something that I get a lot of value out of this. I hope everybody else does too. So we'd like to start incorporating it a little bit more. But call out and thank you to Salesloft, our sponsor for the Zoom meetup and everything. Shout out to Joe Lupo, and big thanks to him for coming and talking to us about Harbor. And thanks to everybody else for coming in. We're going to sign off now from the recording. We can stick around, hang out, and chat for some social time. Moshe, if you could stop the recording.